In this video, I want to explore decimals as they relate to real numbers. So we've talked about in the last video real numbers, including everything on the number line. So we had real numbers, and real numbers could be subdivided into rational numbers and irrational numbers. An example of a rational number would be 2/3. An example of an irrational number would be the square root of 2, or we also used pi. Also included in the rational numbers would be our favorites, which are the integers. So they are a subset of rational numbers, and that would include things like -4, 0, or 1. So those are in fact rational because they could be expressed as not over 0, but over 1. We could express -4 as -4 over 1. Now we want to explore whether decimals are rational numbers or irrational numbers. So let's consider some of those. Let's consider a number like 6.2. 6.2 clearly is on the number line, so it is a real number. But is it in fact a subset of the rational numbers, or is it an irrational number? Well, it's a rational number because you could easily express it as a ratio of two integers. In fact, decimals are very easy to express as integers. Since this goes to the 10th place, or you could think of that, so let's call that the 10th place, we could simply say that this is 62 over 10. If I wrote out more digits and had 6.217, you can see that this goes to the 1000th place. And because it goes to the 1000th place, I could write it as 6,217 over 1,000. So it is equivalent to a rational number. And it's very easy to convert any decimal into a rational number. It's just much more compact to write it as a decimal, and it's much easier to work with arithmetically. But there are other rational numbers which don't give us nice decimals. So you're probably most familiar with 1/3. If you put it into your calculator, you'll get 0.3333, and it just keeps going forever. So is 1/3 a rational number? Yes, clearly it's an integer of 1 over an integer of 3. But 0.333 is only an approximation, so we should probably write little squiggly equal signs. It doesn't actually equal 1/3. If we wanted to write 0.333 as a rational number, it would be 3,333 out of 10,000. And it turns out that is not quite a third. It's a tiny bit less than 1/3. So how could we express 1/3 as a decimal and be exact? That's where mathematicians have come up with the notation that you put a bar over the 3, meaning that it repeats forever. While 333 out of 1,000 is very, very close to 1/3. 3,333 out of 10,000 is even closer. And if we keep adding digits, we can get ever closer to 1/3. So if we went on forever, we would theoretically approach 1/3. Now, what happens when you try to express the irrational numbers as decimal places? So if you take something like, let me switch colors here, the square root of 2, it ends up repeating itself, or it ends up not repeating itself in the pattern. If you begin to write it out, you can write it out as 1.414. Let me stop there. But if you were to take 1.414 and actually square it, you would not get 2. 1.414 squared is going to come out to be, hang on one second, I'm putting it into my calculator, and if I square it, 1.414 squared is not 2. It's 1.999396, which is just a little bit less than 2. So I can get closer to the square root of 2 by adding more decimal places, 1.414, 2, 1, 3, and I can keep going, but the pattern would never repeat itself. In other words, I could never take an irrational number like the square root of 2 and exactly write it as a decimal. I can get very close. 1.414 squared, right here, is very close to 2. It's just a tiny bit under the value of 2. So irrational numbers can never be exactly expressed as a decimal, but they can be approximated pretty well.